Introduction and Learning Objectives.
This lesson covers the basics of centers of gravity and buoyancy. Understanding what these centers mean and the relations between the buoyancy and gravity forces is essential for understanding the subject of stability. The stability of a floating unit depends mainly on the locations of the following 2 points: the center of gravity, G, and the center of buoyancy, B.
Now we click on G to learn about center of gravity. The center of gravity, G. The total weight of a unit is the sum of weight items of ballast, consumable, stored, cargo, hull, etc. W1, W2, W3, or W4 represent weights items that are removable. WL represents constant weights such as hull and machinery, and it is defined as the lightship weight.
The center of gravity, G, is the point at which we can consider the total weight of the unit to act.
Let's see, where is the center of gravity of this unit?
The center of gravity, G, is the point at which we can consider the total weight of the unit to act.
Effect of weight movement on G. In the following exercise, you can observe how moving the weights on the unit affects the position of the center of gravity. Now we shift the weight around. Observe the center of gravity, G, position. If any of the weights are moved on the unit, in what direction does the unit's center of gravity move? It moves in the opposite direction. B. It does not move. C. It moves in the same direction. The correct answer is C. The center of gravity moves in the same direction as the weight. The center of buoyancy, B. The center of buoyancy is the point at which the total upthrust force is considered to act on the submerged portion of the unit. This upthrust force is generated by the water hydrostatic pressure. The hydrostatic pressure of the water exerts a force normal, perpendicular to the surface at each point on the immersed portion of the unit. Now we click on the submerged part of the hull to observe the distribution of the hydrostatic forces. The horizontal components of the hydrostatic forces cancel out, resulting in a zero horizontal force. Now we click on the submerged part of the hull to cancel out part of the horizontal forces. Hydrostatic forces acting along curved or inclined surfaces can be resolved into their vertical and horizontal components. Now we click again on the submerged part of the hull to observe how the forces shown along the bilge radius are resolved into their 2 components. The horizontal force components along the bilge also cancel out, resulting in an upward vertical force distribution. Now we click the submerged part of the hull to generate the total upward force distribution, the buoyancy force.
The center of buoyancy is the point at which the total upthrust force is considered to act on the submerged portion of the unit.
Now we click once more on the submerged part of the hull to locate the center of buoyancy B.
The upthrust buoyancy is the total of all the vertical force components acting on the hull.
Effect on weight addition and removal on B. Now we click on the weight, W, to place and remove it from the deck. Observe the center of buoyancy, B position. Effect on weight shift on B. Now we move weight, W, to port or starboard side, respectively. Observe the center of buoyancy B position. For the conditions shown, which of the points represents the correct position for the center of buoyancy? Option 1 or 2 or 3. Option 3 is correct. The center of buoyancy is always at the center of the unit's underwater volume.